Okay, so this is Dr. Smith. As promised, I have an example problem here to show you how to deal with electric fields pointing in different directions and the vector nature of them. So we've got this charge positive Q that's over here, and over here we have point P, and I want to find the electric field due to the positive Q plus Q at point P. These are the coordinates. So I'm going to start by writing down my basic formula for electric field due to a point charge, which is like this. And great, here comes my cat, Lucy, to walk over the keyboard. And all those noises are coming from Lucy. Come on, Lucy. No, don't sit down on it. Okay. So my apologies. That was cat butt sitting on the keyboard. And come on, stop. Just go away. Sorry, I'm trying to get rid of this stupid. Let's see, let me try to move the thing back in. Just stop. Okay. No, Lucy. I can't undo that, Lucy. I have no idea how to fix. Okay, wait a minute. So here we go. Oh my gosh, I got it back. Okay. So here comes Lucy again. No, don't sit down on the keyboard. Come on. Okay, I know this is rapidly, the entertainment value here is rapidly fading, but okay, so. Okay, I think we're back. So, sorry, electric field, if we have no more feline interruptions, electric field due to a point charge at some location is just K times the actual point charge, divided by R squared times R hat. What does all this mean? We should know, but just to review, R is a vector going from the location of the charge to the location that we're trying to find the electric field at. So I'm going to draw out here. This is our R vector. Okay. And then R hat is the unit vector version of R. And of course, plain scalar R is the magnitude of R. So let me just write down what these R vectors are. R, haha, to, oh, I kill myself sometimes with humor. Okay, so this R vector going from Q to P, you go W horizontally, which is the positive x direction. So it's W I hat, and then you go H up, so that's H J hat. Okay, so then the magnitude of R, which is just the scalar R, is really you just use Pythagorean theorem with the components and get root W squared plus H squared. Okay, finally, the unit vector is equal to the R vector divided by its magnitude. So remember, the unit vector is a little vector that points this way, and the only reason for the unit vector is to get the field going in the right direction. Okay, so that is going to be, then we're going to have the Wi hat plus Hj hat on top, and our denominator will, of course, be root W squared plus H squared. So, there you go. So now, really, now you just plug this stuff in, right? And little q in this case is plus q, or plus big Q. So now the electric field, due to this guy at P, so I'm just going to write at P, electric field at P, but, that's just me being extra careful with notation, is K times our big positive Q there over, now, R squared, this is our R here, our plain scalar R magnitude, so W squared plus H squared. And then we multiply that by the unit vector R hat, and this is a big ugly thing, so we're going to need parentheses. Parentheses for safety. Okay, plus Hj hat over square root of W squared plus H squared. Okay, so what you'll notice here now is that what you're going to get in the denominator, if you simplify this a little, and it's kind of nice to simplify it a little at least, is you're going to take this and recall that root W squared plus H squared, that's not a root of, well, square root of anything really, is that thing. Okay, so here's W squared H squared, what goes inside, to the 1/2 power. Okay, I think we remember that. So that this denominator here is w squared plus h squared to the 1/2. This is w squared plus h squared to the 1. So what I'm going to get is, in the denominator, I'm going to have w squared plus h squared to the 3/2 power. Okay, kq still goes on top, and then out here I'm going to put my wi hat plus hj hat. So this is, your answer there for the electric field at point P. So the thing to notice is you can expect often to get this 3/2 power in the denominator. Don't be surprised when that pops up. And the reason that's there, the reason why it's 3/2 is because you have the 1 there and then the 1/2 there, and they multiply together. So that is this. I'm going to do another video in a minute, which has an extension of the same problem. So stay tuned.